Welcome to Chapter 9. Chapter 9 is going to actually combine both hypothesis testing and confidence intervals with what we call two population samples. And so in each of these problems, they're going to have two sets of data, one from one category and one from another. In the 9.1, we're going to be focused on comparing percentages that are happening. And as we move to 9.2 and 9.3, we're going to be focusing on comparing two means that are happening. And so if we look at this one, it says a newspaper published an article about a study in which researchers subjected laboratory gloves to stress. Among 219 vinyl gloves, 65% leaked. So that's our first group, 219 vinyl gloves, 65% leaked. The other one is latex gloves, and they also did 219. Now I want to mention that they don't have to have the same sample size, and you'll see that in future problems, but they had one. Or they had the same. So among 219 latex gloves, 10% leaked. So you can see there's a drastic difference between the two. Using the accompanying display of the technology results and using a 0.05 significance level, test the claim that vinyl gloves have a greater virus leak rate than latex gloves. Let the vinyl gloves be population 1. Okay, so I apologize, but I already picked the right null hypothesis and alternative. What they're claiming is that vinyl gloves, population 1, have a higher leak rate, so their percentage of leaks is greater than the percentage of the latex. And so that's why we chose D, that the null hypothesis is always equal to, right? And the alternative hypothesis has to be the claim, if it can be, and it can, that it's greater than. So they're saying to look at the technology results. So let me click on this I button, and it's going to load those technology results. Maybe. And here's what we got. So what it's giving us is our test statistics. So all we have to do for this problem number 1 in 9.1 is type in 11.85, which would be rounded to 2 decimal places, and see if it takes it. It does. We can leave our window open here. Identify the p-value. The p-value is, now they want it to only 3 decimal places. Let me check if I put in 4, like it has. Just thinking. Okay, it took it, but I didn't think it would. But we should round to 3 decimal places. Now we know why that's so low. It's low because 11.84 standard deviations away is super far away. So remember what we do. Nothing has changed from chapter 8. The p-value is being compared to the significance level, and it's less than it. So we reject. Every time the p-value is less than the significance level, we reject the null hypothesis. And if you reject, there always is sufficient evidence to support the claim, right? Or reject the claim if the claim is the same as the null hypothesis. And so I'm going to check that answer, and it's going to tell me I did great. Maybe. Eventually. There we go. Awesome. So let's move to the next question. And as it moves to the next question, notice that there's not a box that's going to give us the technology responses. I'm suggesting that you go through the 9.1 homework using StatCrunch and 9.2 and 9.3. I think it's absolutely necessary for 9.2 and 9.3 because they're asking us to use the p-value method, but I think it's also important here. So there's a little bit of difference in this problem, but there's some similarities as well. So let me read across the top. Test the given claim. Identify the null hypothesis, alternative hypothesis, test statistic, p-value, and state the conclusion, as well as the final conclusion that addresses the original claim. That's going to be an upfront sentence in all of these. Among 2,176 passenger cars in a particular region, 236 had only rear license plates. Among 316 commercial trucks, 44 only had rear license plate. A reasonable hypothesis is that commercial truck owners violate laws regarding front license plates at a higher rate than those that have a passenger car. So they're saying that that they're claiming that the commercial trucks, which is that the first one they're talking about? No, it's actually the second one. Okay. Use a 0.10 significance level to test the hypothesis. Test the claim using a hypothesis test. That's part A. Now look at part B. Sorry, I need to get some water. Test the claim by constructing an appropriate confidence interval. I'm going to guide you through that, but StatCrunch is going to make it super doable. So let's be careful. I believe that the computer is always assigning population 1 to the first population. The first population is passenger cars, and they're claiming that commercial trucks have a higher rate. So we want the commercial trucks to be higher. So it's very tempting to choose A, but A is not going to be correct. Let me show you. I'll click and it's incorrect. Now the reason why it's incorrect, somebody's going to say, well, Jensen, it says greater and the claim says greater. Well, what's greater? It is the commercial trucks that's greater, and that's population 2. So it's actually D. So there's that level of thinking that needs to happen in these problems. You have to know, oh, population 1 from the computer's point is always going to be the first one listed. It's good. But when they go to state their claim, they talk about the second one first. The second one is greater than the first. That's a D. And if we do my final check, it'll take it. Awesome. So as we go to do this next one, identify the test statistic, this is when you're going to click on question help. And when you click on question help on the exam, StatCrunch will be there. I'll set it up to be there. And on the final, right? We got one more test coming out. So here we have it's loading StatCrunch. So what I'm going to do is drag this off to the side, and I'm going to bring this back so we can see it. So the way to use StatCrunch to do this is we're going to go to Stat, just like we did in 8.3. And we are dealing with proportion stats. So you're not going to go to Z-stats. It is a Z-score, but that Z-score is this one right here. The Z-stats is for the mean. If we were to go look at the 2 sample, which is what we have, it would have dealt with the mean. What we need is proportion stats. And how many samples do we have? We actually have 2 samples, and they're summarized for us. They didn't give us out a list of a bunch of data. They summarized it for us. So sample 1. Now sample 1's going to be the first one. Look how nice this is going to be. Sample 1's the passenger cars. Remember, they claimed that the passenger cars, well, the alternative hypothesis was that passenger cars were less than the commercial cars. That's the same as what the claim's saying, that the commercial cars is greater. All right, so let's go look at the passenger cars. So I like that they're doing number 1 as the first one. So it says among 2176 passenger cars. Well, that's the number of observations. The number of successes was the number of cars that had only rear license plates, which was 236. In sample 2, there were only 316 commercial trucks observed. Makes sense that it would be far less commercial trucks, and 44 were successful. Now, this might seem a little bit strange. The null hypothesis of P1 minus P2 being equal to 0 is the same as this null hypothesis. If we were to add P2 to the other side, it would come out, it would be P1 equals P2. And so what you're going to want to choose here is the exact same symbol that's over there. P1 minus P2 being less than 0. They're using a technique here that's in most books, and I'm actually surprised that their null hypothesis doesn't reflect that, but it's fine. So notice that with this alternative hypothesis that my arrow's over, if you were to add P2 to both sides, P1 would be less than P2. This is our guy. Notice there's a confidence interval. We're going to deal with that. One thing I want to make sure that we talk about is that you recognize this is a one-tailed test. It's one-tailed because it's only true in one direction. Keep that in mind for a moment, right? Or for later, I guess. Now all you have to do is hit compute. You put in all the data. You have the right null hypothesis checked out. So what's the test statistic going to be? Right here. The z-stat right here is going to be our test statistic. Our test statistic is, and let's type it in there, negative, and they want us to round to 2. Sorry, I put positive. Negative 1.62. And it's going to tell us we did great. Okay, perfect. Identify the p-value. Well, great. Now make sure you round it to where it wants you to round it, because it's going to mark you wrong if you don't. 0.0, and it wants us to go to 3, so 5.3. And we're waiting. We're good. Perfect. So we'll model this again. State the conclusion about the null hypothesis. Well, our p-value is 0.053. Our significance level is 0.10. Our p-value is less than the significance level. 5% is less than 10%, or 0.05 is less than 0.10. So we're going to reject. Every time you reject, there is sufficient evidence. A says that. B has a reject but says not, so it's definitely A. And it's going to say, hey, great job. Now it wants us to get the confidence intervals. And population 1 is corresponding to passenger cars, and population 2 is corresponding to commercial trucks, which is exactly what we had. So let me show you what you can do. If you click on options, one thing you can do is edit. So let's go to edit, and remember what we want now is not a hypothesis test, but a confidence interval. So we have all that information saved. Now, the level of confidence that we have depends upon the significance level. Our significance level is 0.10. But remember, it was only one-tailed. If you picture a confidence interval, how many tails does a confidence interval have? Well, it has 2. So I need to double the 0.10 and put in 0.80. My confidence level, now that may not have made sense. Let me be careful about that. 0.10 is the significance level, and somebody might falsely think that that's 90% confidence. It's not. Because it was a one-tailed test, we need to make it a two-tailed confidence interval. And so we're doubling the significance level to 0.20 and subtracting from 1. Why do we have to double it? Because we're going from confidence intervals are always two-tailed. And our test was only a one-tailed test. So it's a 0.80. And we're going to hit compute. And it's going to tell us our lower limit and our upper limit. Now notice they're both negative. We'll talk about that in a minute. So this was a one-tailed test. So we had to double the significance level and subtract from 1 to find out our confidence level. We put that confidence level in and it ran our limits. They want us to round to 4 decimal places. So we're going to do negative 0.0571 or 572. Should be our lower one. And our upper one is negative 0.0044. And we're going to try that. And it's telling us we're doing great. Now, they're going to ask a question here. So I'm going to wait, and then I'm going to click OK. They're going to ask about the number 0. Now, why are they asking about 0? If P1 minus P2 is equal to 0, then P1 and P2 are the same. Does that make sense? If the subtraction of two things is 0, then they're the same. If my age minus Joy's age is 0, then me and Joy are the same age. Okay, so that's why they're going to ask about 0. So if 0 is in your confidence interval, then that's a fail to reject type of situation. If 0 is not in your confidence interval, then it's a reject. So we're not surprised that 0 is not in our confidence interval. Because remember what you rejected. You rejected that P1 is equal to P2. And we know that's not the case even here. So confidence intervals actually tell us even more. Because the confidence interval limits do not contain 0, that's strong data. There is a significant difference between the two proportions. There is sufficient evidence then. So if there is a significant difference, so the wording will be the same. So as you practice this, it's going to be the same. And it's the same in the earlier videos too and in the book. So you're looking to see if your confidence interval contains 0. If it does not, then there is a difference between the two proportions. And then there is sufficient evidence to support the claim. And we're going to check our answer, and it's going to say great. Now you have more of these same style of questions. So let's see if any look different. This is exactly the same. Let me look at number 4. Okay, I like number 4 because of the claim. So number 4, same style. And what we can do over here in StatCrunch is we can close this window. Right? We're done with that problem. And so my recommendation when you do your homework and your exam is have StatCrunch opened right next to that. So now let's look at this example. So same thing. we're going to test the claim using a hypothesis test. Since an instant replay system for tennis was introduced, at a major tennis tournament, men challenged 1,440 referee calls, with the result that 416 of the calls were overturned. Women challenged 775, with 220 calls being overturned. Use a 0.05 significance level to test the claim, right? So we're only going to test a claim in this one. We're not going to test a hypothesis that men and women have equal success in challenging calls. So we're claiming that P1, the percentage of men, percentage of successful calls made by men, and the percentage of successful calls made by women, P2, are the same. Well, that means that our null hypothesis, well, that's the same as our null hypothesis, so it's got to be opposite, right? So it's not A because we're not claiming one's greater than the other. It's not B because that's not a null hypothesis. Null hypotheses always have equals. It's not C because although we have the right null hypothesis, we didn't claim it was less. It's not F because we can't have a null hypothesis with anything other than equals. It's not E because it can't have a null hypothesis with anything other than equals. It's D because the alternative hypothesis is that they're different. Remember, the alternative hypothesis can only have three symbols: a less than, a greater than, or not equal to. Remember how many tails not equal to was? 2 tails. Good. We got 2-tailed test. Now, we're not going to have to necessarily know that for this problem, but if there was a second part to it, actually, we are going to have a second part. This is great because I see that there's 6 parts remaining, and only 3 of them are testing of hypothesis. These 3 examples should be everything in there. In the homework. They should be sufficient for this problem. So remember what we're going to do. We're going to go to proportion stats, go to 2 samples, and the data has been summarized. Let's go to the men and women. In a tournament, 416 of the 1,440 calls for men were successful. For the women, 220 out of the 777. Null hypothesis is a P1 equals P2 or P1 minus P2 equals 0, and then not equal to is the right symbol there. Awesome. So we're going to click compute, and in an instant we're given the numbers that we need. 0.2855. They want out to 2 decimal places, so 0.29. Well done. Identify the p-value. Also easy. They want it out to 3 decimal places, so 0.775. Great. This is actually a wonderful one to follow up with because I was thinking that it wasn't going to have everything. This is going to have more than what we could hope for, right? It's going to have the confidence interval to follow. There's going to be a part B because there's 3 parts remaining. The p-value is 0.775 greater than, or is 0.775 less than the significance level? And the answer is no. So the p-value is greater than the significance level. So we fail to reject. And anytime you fail to reject, you do not have sufficient data. So we're not able to establish. Whoops, sorry, I'm having an internet issue there. So let me check that answer again. Okay, perfect. All right, hopefully my internet holds out. So now they want the confidence interval. Now they're helping you out. It is a 95% confidence interval. Remember, it was 2-tailed. The hypothesis test was 2-tailed. And so the the confidence interval associated that would have the exact same significance level of 0.05. So we keep that 0.05 because the 2 things match. It was a 2-tailed test, and confidence intervals are always 2-tailed. Just keep the 0.05. In the previous example, we had a 1-tailed test, and so it wasn't the same as a 2-tailed test. We had to double it so that it would be the same. Remember, we click edit. We don't start from the beginning, and we choose the other option. And by default, it chooses the most common one, 95, which is what we have. So all we have to do is compute. Now take a look at what happens here. This is why this is an excellent follow-up one. We get negative 0.0 and they want 3.034, and this is positive 0.045, and we'll check that answer. And it tells us we did great, right? We just plugged that in and everything's good. Now, because the confidence interval does include 0, notice zeros in that interval, which means P1 minus P2 could be 0. And if it could be 0, then they could be the same. So there does not appear to be a significant difference between the two proportions, and there is not sufficient evidence to warrant rejection of the claim. So the not sufficient evidences will always match, or like we saw in the last one, sufficient evidence. So this is great that we happen to get one that was a fail to reject, because now you can see with 0 in that interval, P1 minus P2 could be 0. If it could be 0, P1 equals P2. And so we don't have anything to justify that there's a significant difference between the two. They could be the same. And so we'll just check that answer and be done with this problem. My promise to you is all the 9-1 problems, there's only 8 of them, will be like this. The very first one, oops, I'm sorry, I didn't realize there was a last one. Based on the result, does it appear that men and women may have equal successes in challenging? The confidence interval suggests that there is a significant difference. Nope. The confidence interval suggests that there is a significant difference. Nope. The confidence interval suggests that there is no significant difference between the success of men and women. It seems like we're just restating what we wrote, but they like it. Okay, so as you go to 5, same thing. And if we go to 8, like if I just travel down here to 8, and we look at number 8, it's going to be the same thing, right? We are going to be doing the exact same problems that we did in the last one. So maybe you want to do one more with me. I'll do one more while we're here, and then we'll end this video and get it processed for you. It takes a bit longer when I do it by a screen savings. So let's just read the claim. The claim is that Echinacea has no effect on the rhinovirus. If something has no effect, then there's no difference in the percentages. The percentages are the same. So the claim is that the two percentages are the same. So if we look back at the data, in one group they were given Echinacea, in another group they were given a placebo. They thought they were getting the medicine, but they really weren't. And so the claim is that they're equal to. And so we're looking for an alternative hypothesis that has actually a not equal to. Again, F's the only logical choice. Can't be C because we're not claiming one's bigger than the other. Can't be B because we're not claiming one's smaller than the other. Can't be A because it doesn't have the right null hypothesis. Can't be D because it doesn't have the right null hypothesis. E because it doesn't have the right null hypothesis. So you want to do this relatively quickly when you're on the exam. And so you don't want to look at look at problems. So let's go look at proportion stats. We're dealing with 2 samples. It's all been summarized for us. Let's go talk about the first group. 47 out of the 52 developed the rhinovirus, and 80 out of the 95 that were given the placebo. And this is the right null hypothesis. We want the one that's equal to 0. This will always be 0, by the way. And P1 minus P2 not equal to 0 is right, so we just hit compute. We come over here and type in our Z value, 1.04. And it's going to tell us that we're good. We type in the P value. And this is the best way, like I mentioned, to go through this. And they want us to round to 3, so I do 297. So make sure you're rounding right. Now the p-value is really high. Certainly it's bigger than the 0.01, and so it's greater than the significance level, so we fail to reject, and there is not sufficient evidence. Every time you fail to reject, there's not sufficient evidence. We check that answer, and we say, okay. Now, They're helping us out. 99% confidence interval. The reason why it's 99% and that matches really well with the 0.01 is because of the two-tailed test. So what do? Remember, we don't go back and start over. We click Options, Edit, and we choose the other option. And we don't want a 95% confidence interval. We want a 99. And we compute. And here's what we have. Notice that we're not going to be surprised that zero's in the interval because we failed to reject. Negative 0.081 is the low value. The high value is 0.204. And we'll check that. It says nice work. Now, does the interval contain 0? It does contain 0. It includes 0. So there does not appear to be a significant difference. Again, if 0 is in that interval, then P1 minus P2 could be the same. So there does not appear to be a significant difference between the two proportions, and there is not evidence to support the claim. And then it's going to have its follow-up question, just like your exam will. And so based on the results, does echinacea appear to have any effect? And what we said is that it does not appear. I'm not quite sure why they're doing that because it does seem redundant from what we do in part B of that second part, but they do. So all the questions are the same. Have fun with it. Use the StatCrunch, and we'll get this video posted.